Hello, this is Dr. Oz. So I would like to solve in this video the par manufacturing problem. And I have here 4 departments, and I have 2 different types of bags, standard and deluxe. And every standard bag will require 0.7 hours of cutting, 1/2 hours of sewing, 1 hour of finishing, 1/10 hours of inspection. Every deluxe bag, on the other hand, will require 1 hour of cutting, 0.883, which is 5/6 hours of sewing, 2/3 hours of finishing, and 1/4 hours of inspection. Marginal costs associated with these products are 70 and 150, and I have these many hours available for me in each department. And the demand is given here based on this, and profit contribution could be anything like nonlinear function like that. So that's why this is nonlinear optimization model. However, I'm not gonna use really this function to solve it, but I could choose that as an objective function as well. So I just show you as an example here how a nonlinear optimization function could look like. First thing first, objective, which is maximize profit, and I will calculate profit again, not based on this. It could be I'm gonna calculate it based on revenue minus expenses. Revenue minus expenses. All right, so I will calculate that right here. I like to use green cell for my objective function, and here I'm trying to really decision variables I'm trying to decide here is what should be the price for each type of bag. All right, so I'm trying to figure out the price. I will make them yellow. However, price will not be my main concern in when it comes to my constraints and the objective. Instead, I'm more concerned about quantity sold, which is a function of price for these 2 bags. So what I'm gonna do is I will calculate quantity sold based on price based on these relationships. So quantity sold for standard bags is 2250 minus 15 times price of standard bag, and for deluxe it's gonna be 1500 minus 5 times price of deluxe. All right, so these are quantity sold, units or demands for my model, depending on price. Let's say if this price 100 and this price 300, my 200 looks like so expensive, 250. I will have this much demand for standard, this much demand for deluxe. All right, so I'm trying to figure out these yellow values. Now let me just calculate my objective function based on, again, not this. I just want to solve it for revenue minus expenses based on marginal costs given to me and based on price. So this times this will give me my revenue from standard bags, plus this times this will give me the revenue for deluxe products minus the cost. This times the marginal cost of standard minus cost for deluxe is this times this. All right, so this is your unconstrained model, and I'm trying to maximize this. So if I just solve this problem without the constraints, basically I could get the solution which will give me an upper bound for maximization problem. Again, under data tab you should have solver. If you don't have solver, go to file, options, add-ins, analysis toolpack, go and make sure that your solver is checked. Click OK. It may take a minute or two. Then on the data tab, go to solver, and then your objective here is your green cell. Click on that, and it's a maximization problem. Let's choose our decision variables, which are yellow cells. Highlight these 2, enter, and then I will use nonlinear program, solve it, and looks like there's no convergence. Okay, so what is going on here? Oh, okay, because the if I do solve this problem this way, basically I'm getting, I guess, infinite profit. So why is that happening? Oh wow, I can charge infinite money. but that doesn't make any sense, right? So I cannot just charge that much money and make money. So so what's the problem here in terms of the relationships? Let's figure that out. Okay, so to figure that out, basically what I'm gonna do is I'm gonna look at my formulas one by one to see whether I can debug this issue, which is a big part of analytics process, is the debugging of your model. All right, so if I do that, so let me just look at the profit calculation. Basically G7, this value times G8, okay, plus H7 times H8 minus G8 times that costs, and minus H8 times C7. That looks good to me. Let's look at my quantity sold situation here. Oh, okay, here I forgot to put the price. Of course, I cannot have infinite here. The higher the price, lower demand will be, which perfect. And here, okay, 5 times PD. That's pretty good too. All right, so let's try to solve this problem again. Data solver, and solve this problem again. Optimal solutions font. Okay, so now what is going on? Still, I'm not getting the solution that I would like to get. Do I still have an issue? Okay, finally I got it. I think there was a problem with the solver. I just solved it again. Basically, I got the solution. So the best solution I can get is $52,125 profit by charging $110 for standard bags and $225 for deluxe bags. Perfect. But this is an upper bound form. So this is something that's not reachable because this is not a feasible solution. Why? Because I have constraints, third component of my model. Let's introduce my constraints subject to left-hand side values versus right-hand side values. All right, so the right-hand side values are given to me: 630, 600, 708, and 135. And I can spend more than those are, so these are less than or equal to constraints. And my left-hand side values are some product, because these are, again, linear constraints. These are my coefficients, comma, these are my prices. I would like to lock my red cell so that I can drag it down. And the way it is, as you see here, is that's not feasible because this is violated, even this one is violated. All the constraints are violated pretty much. So I don't like this. This is not a feasible solution. Again, this was upper bound for me anyway. So now what I'm gonna do is I would like to solve this problem with these constraints. So I will add those constraints to my model to see whether I can make something close to this at least dollars. So data solver, and let's add our constraints. These values should be less than or equal to these values. Click OK and solve this problem. And click OK, and looks like this is my optimal solution, which is $49,921, and all the constraints are satisfied, and I should charge $119.35 for standard products and $238,036. So if I create sensitivity report though for unconstrained version of this, how exact calculate this, right? We talk about the intuition of this in last video, but if I solve this again without the constraints and get a sensitivity analysis, you will get this result. So basically, let's 1 second. I want to make sure that everything is good. Okay, this is good. Oh, okay. Not the if I do unconstrained ones, sensitivity analysis, basically I'm not getting anything because there is no constraint. Basically, there is no Lagrangian multiplier because there is no constraint. If I again solve this problem with the constraints, again, add my constraints, left-hand side values less than or equal to these right-hand side values, and okay, solve it and get sensitivity analysis. Now you will see that my Lagrangian multipliers are here. So as you see here, cutting department is the only one with the Lagrangian multiplier. So if I go to that direction, basically that's how you solve how you improve the objective. Why? Because as you see, cutting department is the only one with binding constraint, because as you see, I had 630 hours available and I'm using all of it. That's why I have Lagrangian multiplier. If I want to improve this model any better, I need to work on cutting department hours. That's it for this video. Until next video, enjoy business analytics.